Good afternoon, everyone. We're really excited today to welcome you to today's webinar that we are hosting for HP. So this webinar is on transforming the packaging industry by accelerating the transition away from single-use plastic to sustainable molded fiber solution. So we are joined today by Eric Trollson, who is the Director of Packaging Design and Procurement at HP Incorporated, and also John Bryden, who is the Molded Fiber Advanced Tooling Solution Architect at HP Incorporated. So HP Advanced Tooling Solution is a breakthrough technology to produce molded fiber tooling. So without further ado, I'm going to pass over to John and Eric, who will be hosting today's webinar. Please ask any questions throughout the session, and we'll be answering those with a Q&A at the end.
Okay, thank you very much for inviting us to the Packaging Innovation webinar. I'm Eric Trollson, and I'm the end-to-end sustainable packaging lead for HP's Molded Fiber Advanced Tooling Solution. And it's a pleasure to also have John Bryden here. John, want to introduce yourself?
Thanks, Eric. Yes, my name is John Bryden, and I'm HP's solution architect for our offering to the molded fiber industry.
In terms of the topics for today's webinar, we've got, we're going to start with some information on sustainability and HP's commitment to sustainability and how that actually plays into packaging goals and commitments to reduce plastics packaging. We think that that will resonate with a number of you as brands and brand owners. And then move into our molded fiber tooling solution, its benefits, as well as how the actual value proposition works. Okay, starting with HP's sustainability goals, we have a big focus on sustainability and our commitment to make life better for everyone, everywhere. And our recent broad goals around sustainable impact support that theme as well. As part of our overall sustainability focus, HP made commitments regarding packaging and specifically reducing the use of single-use plastics in packaging by 75% by the timeline of 2025. This goal was actually set last year in June of 2020, and we're making solid progress towards reaching that goal. And we've also recently broadened our set of sustainability goals to include reaching 75% circularity for all of our products and packaging by 2030. And this really drives a focus on both products and packaging made from recycled, reused, or renewable content as well. And we measure that by weight. We also know that many brands, many of you in the audience are also focused on sustainability and transitioning your packaging solutions to more sustainable materials. And for HP and many in the industry, moving away from plastics and to molded fiber or fiber-based packaging is one of the best ways, to do the best for the planet and move away from plastics. This is kind of our banner of our goal. And, we set this bold goal last year of eliminating 75% of our single-use plastics. And our baseline for reduction is the plastics that we used in 2018. We've started this journey and really focused on changing our designs and changing our approach to incorporate fiber-based packaging. An example is shown on this slide. So for our personal systems team, here's the type of change that we're driving. We're aggressively shifting from our notebooks, for instance, and desktops from expanded polyethylene or expanded polystyrene that are shown in the top pictures on the right to sustainable molded fiber. We're driving this type of change across the board, not just in our PC products, but in our printers and wherever we have packaging, we're really focusing in on reducing plastics. We're also still meeting the aggressive and the protection requirements needed for the product while eliminating the plastics. And we aren't stopping at just the cushions that protect the product, although that's most of the plastics that has been in our designs, but we're focusing on bags, films, any other in-box plastics and shifting to more sustainable materials. Where plastics may still be needed, we're looking at more sustainable plastics, recycled content, bioplastics, or even just alternatives made from paper, for instance. And so when we launched our goal last year, we also produced a video that describes this transition, and I'll play that video for you now. Okay, so, that's a great video that summarizes both the problem we have with plastics in the world and the lack of recycling systems and recyclability of plastics, and the way that HP is using molded fiber to help solve the problem, at least for the products and the packaging we generate. Now, in HP's journey to use molded fiber, we've encountered some challenges and barriers, especially with the existing tooling technologies used in the industry. In general, they're difficult to convert our packaging because the tooling is, a big barrier in terms of long lead times, development cycles, long fabrication times to make the tools themselves, and limitations of analog machining and wire mesh technologies is really at the heart of those barriers. For our HP suppliers worldwide and molders, the tooling maintenance is difficult, it's time consuming, it does limit uptime and involves specialized labor costs as well, specialized labor and resulting costs to address maintenance type of issues. And lastly, part quality in molded fiber can be inconsistent with traditional tooling. The tools are based on CNC machining with drilled vacuum holes, as well as a woven wire mesh that you can see on the top picture there. That's cut, it's hand folded, it's hammered, welded in places. Sometimes certain shapes are really difficult to produce repeatably, and it has a lot of drawbacks. So in that journey, we also have a 3D print business, and a few years ago, we started to ask ourselves, could we apply our 3D print technology to the molded fiber industry, and especially the tooling solution? So fast forward a year and a half or two, we actually have developed a digital tooling solution based on HP's 3D printing platform and adopted it to the needs of the molded fiber industry. Our solution provides the ability to market products better, with faster time to market, consistent high quality, brand differentiation through the use of textures and customization of the parts, very competitive costs, bringing molded fiber to more brands and making it more affordable for them to move to sustainable packaging. And HP's digital tooling design flow, combined with our multi-jet fusion 3D print technology, is really the key enabler to this tooling solution. The solution offers three clear benefits. First of all, it helps molded fiber manufacturers in terms of speed and time to market. Second, it makes molded fiber packaging even more sustainable. And last, it also enables brand differentiation through packaging designs. And let me go into some detail on those three advantages. In terms of time to market, we're all challenged with ever faster product development timelines. Our tooling solution helps expedite the design process, focusing on both part and tooling designs that help accelerate molded fiber product development. It's all enabled by HP's digital technology and process flow. If we look at the actual typical production tooling time, we can actually help shorten time to mass production with production-ready tooling in as little as 2 weeks after finalizing your design. We can add custom markings without adding fabrication time, and we can get production equivalent pulp samples quickly off the same tools that can be used in normal production, because the process we use for any prototype tooling is also the same for production parts. This translates to between 3 and 10 weeks of time saved on a typical tooling development cycle. In addition, from a quality perspective, we can also achieve consistent, better quality parts with sharp, clean edges and borders and crisp, legible markings that are enabled by HP's smart screens. In addition to the fine edge quality, we can now combine superior legibility and definition plus rapid screen swapping to yield personalized packaging campaigns for your brand. HP molded fiber advanced tooling makes part marking simple, including brand logos, recycle logos, text and part numbers, even textures that can be incorporated in the printed screen. Crisp edges make markings much more legible. Plain commodity parts can be transformed into higher value branded parts with the change of a screen. HP Hot Swap Smart Screens make that change possible in as little as a minute while the tool remains in the machine. As an example, the image on the right shows how HP's tooling can help build a personalized packaging campaign. Western Pulp used our tooling to demonstrate how easy it is to change branding and marking of their packaging and sell direct to wineries potentially. The combination of having screens that are easily changeable while the tool is still in the machine and the ability to integrate features of fine detail into our HP smart screens is the key to opening up opportunities for brands to have customized features on commodity parts. Several molded fiber manufacturers have commented on the crisp edges of the markings that HP's screen woven wire, which forms a radius as it bends around a formed shape. The HP smart screens have markings that are printed with sharp edges, resulting in more legible part marking. Western Pulp described the marking results as spectacular, and another molder similarly said that the results are far beyond what they have seen off any other tool. This next slide actually shows how another example of how our digital workflow and the technology enables embossed logos, textures, model numbers, or traceability information. And we can place that information on both horizontal surfaces as well as the drafted surfaces as well. So anywhere on that part face, we can actually place these textures as well with our tooling technology. And so, you know, sustainable packaging does not have to be boring. The example shown here is our own HP Desktop Mini application, where we've been able to enhance the prior plain packaging with textures and branding inside and outside surfaces to make, you know, forming those boring trays, instead of being boring, they're carrying the HP brand. And they could carry your brand as well with a little extra creativity and surfaces to carry your message, whether it's your brand, sustainability messaging, or whatever you'd like to place on those surfaces. It's very easy with 3D print technology and HP's tooling solution. Here's another example. We've worked with Veritiv, and this example shows really the potential of customized molded fiber packaging. And it's really only possible with our tooling solution. This is one of our foundational customers, Veritiv, that showing the potential of branding with this particular tooling. And you can see that the screen is on the left and it prints the part on the right, which shows a lot of fine detail. And this one happens to be, you know, a wine bottle example on the right as well. So you can see there's a lot of really interesting things you can do, opening up the whole world of customization on our molded fiber parts. In addition, HP is developing and developed an AdvancedPro Transfer technology, which really enables second size smoothness without afterpressing in many cases. So a lot of times problem with molded fiber is you have one side that's smooth and then the other side is usually very coarse. Well, with this particular technology, you can have, smoother side, both the transfer side as well as the tool side. You can have low draft parts, and you can actually make those parts with less warp afterwards, perhaps without pressing as well. So we're actually conducting pilots of this technology now that offers those benefits as well to customers. One of the other key benefits of our solution is really making molded fiber packaging even more sustainable. So how do we do that? First, we've been able to optimize and reduce the fiber material consumed without actually decreasing performance. And we do this through better first pass retention of fibers and more even wall thicknesses throughout the part. And we can implement that through the use of actual tool blockouts. So you don't actually use fiber in places where you don't need it. And we also have technology that John will talk about that allow you to direct the flow by actually tiny level. The holes that we use for perforations, we can turn those on or off, therefore directing the flow of the slurry into the part. Also, the screens and the resin that we use in our tools is actually made from sustainable material. The raw material is actually made from vegetable castor oil as well. So we're even thinking about the materials that we use in the tooling and trying to find sustainable solutions there. Lastly, the parts that are produced and these enhancements really result in lighter molded fiber parts. And the result of that also is lower energy to dry the parts. And it's all contributing to a lower carbon footprint impact for both the tools and the production parts as well as they travel through the typical supply chain. One other benefit is around operational efficiency, and we've achieved improvements through improved dewatering times. And this is the time it takes to actually dry the part from slurry into a finished part, shorter cycle times, and reduced maintenance as well. This all makes for more efficient molded fiber operating and operations by molders, and should translate to lower costs as well for the end customer for the parts. We also reduce the material waste through additive manufacturing and making our tools versus traditional subtractive processes like machining, CNC machining. All of those are subtractive, and the metal that you're taking away and making those parts is really wasted. Lastly, I want to show a proof point. This was actually the desktop mini I referred to earlier, but this was our first major HP product. The desktop mini was launched in February of 2020 on a very high volume PC that's distributed in North America. We partnered with our foundational customer Veritiv as well as Molder Fiber Innovations and achieved improved quality, lead time, and actually cost improvements as well. And that has led HP to really evaluate every possible molded fiber design to see if it can be used successfully with our advanced tooling solution. Therefore, HP is helping reach its own sustainable packaging transformation. And we hope that by sharing this with other brands and the whole supply chain, will help convert other brands and help them reach their sustainability goals as well. Okay, so now I'm going to hand it off to John, who will really share a bit more detail on how we achieve these results. John?
So yeah, I'm John Bryden, and I am the solutions architect for HP's molded fiber solution. And I'm going to talk about how we have applied digital manufacturing and design to bring new value to an industry that's not evolved much in decades. Many of the pain points that Eric highlighted earlier are associated with the manual nature of the manufacturing of molded fiber tooling. So we are replacing the manual processes with digital design and manufacturing. And therefore, we're able to accelerate time to market, increase the sustainability of molded fiber packaging, and open up new opportunities for easy brand differentiation, as Eric was pointing out. Digitally designing tooling offers so much value that traditional tooling cannot, but it requires powerful and unconventional design tools to deliver the fine detail necessary for the molded fiber process. We have leveraged traditional and novel CAD tools to accelerate the delivery of design files that only HP's 3D printing technology can deliver. We're fortunate to have technology that is able to produce the screens, which are the most important part in making molded fiber products. We're helping to accelerate time to market by eliminating the need for a separate prototyping tooling stage. The traditional part approval process is a two-phase process whereby a prototype tool is used first to verify a part design. However, that prototype tool usually cannot deliver parts with the surface quality of a production tool. And the prototype tool cannot be used for mass production because it's either too weak to support the forces in the process, or it gets clogged too quickly, so you can only produce a small number of parts. Whereas with HP's sample tool, it's ready to start ramping production as soon as parts off of it are approved. And additional copies of the tool can be delivered much more quickly than traditional tools so that you can get to full production capacity very efficiently and quickly. Furthermore, with HP's tooling, there are fewer parts to design and deliver. Traditional tools have to be sectioned into several pieces in order to accommodate the complicated manufacturing process. Whereas with the HP tool design, it's much simpler. There's no splitting of the tool. Of course, there are limits to the size of our 3D printing capability, but if the tool fits inside our build volume, you have just a few pieces, and it only takes 1 or 2 days to produce the design. And we've even been moving towards automating that entire process. So the time to get to a design is going to drop dramatically. Even the fabrication process is faster with HP's solution. As you can see, there are many sequential steps in the traditional tooling fabrication process. Whereas with HP's tooling, it's much more efficient because you can print all of the parts of the tool simultaneously. The screens don't have to wait for the form to be made, whereas in traditional tooling, you can't make the screen without a form. So that's a benefit in the fabrication process. And even in assembly, you've got fewer pieces to put together because we're able to integrate parts that are necessarily separate with a traditional tool design. Because HP's smart screens are seamless and they integrate features that are critical to the manufacturing process, such as the decal ring or hold downs and blockouts. Those are all technical things, but they are crucial for producing parts. Because they're integrated in HP's smart screens, the artifacts that they often create on the parts and result in poorer part quality are eliminated. So we're able to have the crisp edges and the very legible markings and the real sharply defined holes that Eric was referring to earlier. The markings that can be digitally integrated into our screen can achieve unprecedented legibility and customization, right? The artwork that the Veritiv sample shows there just cannot be done with a woven wire screen. And then in terms of efficiency, the digital design enables HP's tools to make better parts. And we'll talk more about that in a moment. So engineering of fluid pathways is the way we are helping make molded fiber packaging more sustainable. We worked with an independent researcher and testing company to test some of the HP value proposition. Their results proved that with HP's solution, we're able to do just that, make packaging more sustainable. They found that because of the way we engineered those pathways, we're able to make equivalently strong parts with less material, less water, in less time. And because you're using less water, you're also using less fuel to dry those wet parts, thereby making the part even more sustainable. And in addition, because we're able to make those parts as strong with less material, they're going to be lighter. And when you're shipping many products packaged in molded fiber, that molded fiber contributes to the weight that needs to be shipped, and therefore lighter parts can reduce the carbon footprint of the entire shipment. We're also making better parts with our engineered fluid pathways because many parts require additives. The use of additives is dependent on the efficient flow of the slurry in the tools. So we are able to eliminate or reduce the amount of additives needed to create the properties that those additives are important to add to the slurry. These two parts show the result of an additive, in this case, a dye, being used in traditional tooling, where you can actually see where there's a lot of dye and a little bit of dye because it's not dispersed evenly. So a lot of molded fiber manufacturers avoid making colored parts because it's hard to make a consistent colored part. However, if you use an HP tool where the fluid flows much more evenly across the tool, that additive, in this case a dye, is spread much more evenly throughout the tool. But dye is just one type of additive. There are many products that need grease proofing or waterproofing, and those are additives in the slurry that need to be distributed evenly. One customer reported to us that when they tested parts off of the HP tools, the performance in their grease-proof test was many times better than the performance of the parts that they were getting off of their traditional tools. So performance is one way brands can differentiate. And through the efficient use of additives, HP's tooling helps drive better performance. The HP AdvancedPro Transfer tool that Eric mentioned before is another way that we're driving better performance and bringing branding opportunities. It's a digitally designed screen that is used in combination with the most least value part of a traditional tool, which is the transfer screen. And with that additional screen, we've transformed that part of the tooling into a value-added opportunity to deliver the smoother second side surface that can be with low draft walls or even zero draft walls, and with markings. So you can now have a part that has a logo on one side and some other markings, whether it be some environmental messaging on the other. And these are opportunities being opened up for lower cost packaging solutions, where you may not be able to afford the expense of thermoforming parts. So this is all brought about by the AdvancedPro Transfer, but it's doing more than that. It's helping the molded fiber parts to become even more sustainable because we can remove additional water from the part from the second surface through the enhanced transfer, thereby reducing the fuel needed to dry the part and reducing the tendency to warp when you're drying the part. So higher yields, less fuel used, a more efficient process yields a more sustainable molded fiber packaging. And finally, we are taking this to another level by applying even more engineering capabilities that will allow us to further accelerate the delivery of production optimized tooling and improve sustainability. Usually fiber is deposited more than is necessary for meeting specifications. I mentioned previously how we were able to prove that we could make a part as strong with fewer fibers. In the picture on the lower left, you can see what is a common situation with molded fiber parts. There's a lot of excess fiber going to areas of the tool that it's really not needed for. But with digital design of screens, guided by computer-aided engineering of fluid dynamics, we're starting to design tools that will make molded fiber packaging even more sustainable. As you can see in the video, we have the ability to decide which pores in the screen should remain open or closed to provide the best quality molded parts. You cannot do that with traditional woven wire screens. It's just not possible to close off individual pores. Combining this capability with the ability to analyze the flow around and through the geometry of each tool, we'll be able to skip the iterative process of getting a tool ready for production and provide tools that lay down fiber evenly, avoiding the unnecessary waste of fiber shown in that picture at the lower right. And moreover, we'll be able to make tools that control the laydown of fiber to provide more fiber only where it's needed to meet the needs of packaging and offer differentiated designs. So thank you very much.
Well, thank you so much. That was such an interesting session and we've had so many questions. So I've got a few that I'm dying to ask. So first of all, why would you say is HP interested in molded fiber?
So
John, I think.
Can you hear me?
Yeah, we can hear you.
All right, sure. Well, the reason HP is interested in molded fiber, really at the core of everything we're doing at HP, we've made a commitment to the environment and sustainable impact. And really, molded fiber is part of that commitment as well, not only for HP as our packaging and moving away from plastics, but also driving the industry and enabling the industry to also move away from plastics packaging and towards molded fiber. And so it is at the core of what we're doing, and many of our goals, as I mentioned, our goal of moving away from plastics as much as 75% by 2025. Well, the primary path to doing that is via our molded fiber designs and through this process.
Brilliant. Okay, and then next up, so it's believed that molded pulp holds good for weight up to about 15 kg. Do we have a solution to replace plastic products such as foams, which are used for products weighing more than 15 to 25 kg?
Yes, that's a very good question. My team at HP, we've actually had success in packaging heavy, sensitive products up to 40 to 45 kilograms. And they've been successful in meeting all of the same stringent ISTA and internal HP test requirements. So molded fiber can be used in those weight ranges. It is true that fiber is not as resilient as foam. It doesn't necessarily bounce back. However, with careful design and careful tooling, we've been able to achieve passing results and also have a much better impact on the environment with the fiber-based packaging versus a foamed plastic.
Brilliant, which actually leads me perfectly on to the next question, which is, what is the level of sustainability of the material used to produce HP molded fiber advanced tooling?
I guess I can take that. We use plastic, and plastic is what we're trying to get rid of, right? But of course, our tooling produces the many packaging parts that will be molded fiber. But the tooling is made of a nylon that comes from the castor bean. So it's organic in nature, it's not petroleum based. So it's much more beneficial to the environment than a petroleum based plastic.
Okay, brilliant. And is it reusable? Is it reusable fiber use as well?
So the plastic tooling itself is recyclable. And our manufacturing process is a 3D printing process that makes use of virgin powder and recycled powder to make the actual nylon parts. And those tools eventually can be recycled as well and turned into other products, but that is a separate waste management stream.
Yes, and one of the questions we've also had is, how do we go about using this technology presented?
So we are offering our tooling solution to the molded fiber industry, and there are molders that make packaging and products for branded customers, and we're reaching out to brands as well who are interested in making their packaging more sustainable. Eric, I'm sure, has more to say on that topic.
Yeah, we have a number of brands and a number of molders that are eagerly reaching out to try our tooling technology. And they're seeing the benefits of our tooling technology in terms of increased productivity, and other benefits, the things we talked about in terms of achieving details in the molded fiber parts that you just can't achieve without a 3D print type technology.
Absolutely. And will the pulped parts look different than using traditional tooling?
So some of our customers have said they look a lot better. They prefer them, and that's really related to markings, logos, but also the edges of the products can be quite crisp without needing to be cut. So some molded fiber parts need to be die cut in order to have a decent edge. We can produce parts that they're not quite as clean as a die cut, but they are much crisper than a typical molded fiber product. There are other qualities of the molded fiber part that some of our customers say our tools produce a better part than what comes off of their woven wire traditional tools.
Okay, brilliant. And one of the other questions we've had as well is, can you say a little bit more about the fiber itself? So is there a need to use proprietary materials? You mentioned something about castor oil, or can pulp be used?
So the castor oil is the base material that our plastic tools come from, but our tools are used to make molded fiber parts of a variety of fibers. So in North America, there's a lot of use of cardboard containers that are recycled, or old newspapers. In other markets, bamboo is used, or sugarcane. And our tools are being sampled and used in production with a variety of these, and we intend to optimize our tools to enable as many of those wood-based pulps as well as non-wood-based, which is an area that's growing.
Perfect. And another question that we've got as well is, what consideration should I factor for designing packaging for HP MF Advanced Tooling Solution?
Well, it's our goal to be able to do anything that molded fiber packaging designer does today and more. So if you are making molded fiber packaging, you already know that there are manufacturing constraints about draft. We are going to be able to deliver parts equal to and with the enhanced transfer, or what we call the AdvancedPro Transfer tool, enable even a lower draft and markings on both sides instead of just one. So if you think about HP's tooling solution, you don't have to do anything special for it, but you can do more with it.
Absolutely. And what would you say, when we're looking at input, what input does HP need to design a tool set, for example?
The input is the same as you would give to the manufacturer of your packaging part today. So typically a customer will say, hey, I want to protect this product, and a packaging engineer would design a packaging part to protect that product. And then that part, the molded pulp packaging part, we would receive a file for that. And then we would create tooling to make that part. So a CAD file of the packaging part in a format like a step file is what we would use.
Okay, brilliant. And is the goal of HP to selling tooling or to license the technology and methods?
Well, our business right now is to sell tooling to the industry, and that's the beginning of our journey. Let's put it that way.
Eric, did you have anything to add to that?
John hit it very well. So yeah, we're providing tooling as a service now. We are looking at other business models as we grow the business, though, too.
Yes, absolutely.
Now,
So
I will add one thing. The question wasn't this, but it's often asked, and it is, can we buy the printers and just do it ourselves? And the answer to that is no, because there's a lot more than just the printer that goes into it. Even if we sold a printer, you couldn't make the files that the printer prints to make the parts. Traditional CAD tools can't generate these files.
Okay, brilliant. And another question. So we've heard it's a great presentation, and someone said that they love your shirt, John. And
Thank you.
The question that they've asked is, have you had to invest a huge amount of money into this?
Into my shirt? No.
Well,
but,
not into maybe the shirt.
Let's just say that it's not a simple thing to produce a molded fiber digital solution, right? We had to develop the software to generate the part files that could be printed with our printers. We had to customize our printers to print something that other 3D printers cannot print, because our technology has some capabilities that others don't. So yes, let's just say that we've invested a lot because we see the opportunity, and we're committed to helping the world make the transition to a more sustainable planet.
Amazing, amazing. So in terms of speed, is sort of like through the output of the finished molded parts comparable to normal molded pulp products?
So the production of the molded pulp parts is dependent, the speed of that production is dependent on a few things, and many of them are around how much water is in the parts, because you need to dry that part, and converting that wet moist part into a dry finished part takes a lot of energy, time, and dollars. So we are actually working to make a part that is dried more efficiently. It has less water in it and uses less energy. And also we expect to have less fiber performing equally well to a part that today requires more fiber. So we're going to be speeding cycle times, lowering energy, making the whole process more efficient.
Brilliant. And who owns that tool design? So would my files be safe with the solution that HP offers?
Your files are your property. They're of the part. We develop tools to make your parts, and those files are confidential. They're not shared with any other customer, but we don't even share them with the customer. There's proprietary technology embedded in the files. So HP owns the tooling files, you own your part files.
Okay, perfect. And can the tools be used on TPM machines?
So TPM is making machines for thermoforming process, and the tools that we're making currently are able to be used in the first stage of making thermoforming parts, which is to gather the mold, gather the fibers onto the mold and deliver that wet part to the next stage, which takes that wet part and presses it between heated dies and gets the water out of it and makes it a smooth, thin part. We do not yet participate in that part that requires high temperatures and metal. We intend to participate in that as well, but our tools are delivering wet parts with less moisture content to make thermoforming process more efficient.
Brilliant. And someone's also asked, can they order just the screen, or do they need to order the full tool set?
They need to order a full tool set, and if they want to replace the screen for some reason, change the logos or the markings on it, they can order a replacement screen.
Okay, brilliant. And where is the HP MF Advanced Tooling solution available? Like, which countries? Is it only in the US at the moment?
Currently, we're developing the solution to be available in North America, in Europe, and we also have plans to expand to Asia, and we're doing some pilots there as well. We want to ensure that the value proposition is sound in each region and that we can ramp the business up appropriately.
Very exciting. So a lot of new developments to come then. So in relation to the TPM, what kind of machines are you testing with customers?
So the machines that our customer has, they're the ones that we're testing on. So there's a bunch of vertically reciprocating machines. There's a bunch of multi-drum rotary machines. There are pick-and-place rotary machines. There are reciprocating rotary machines. There are a bunch of thermoforming processes. But again, we're participating in the first portion of that process, the forming process. Not the thermoforming, but the forming.
Okay. And are there any samples or prototypes available yet?
Yes, we have both tooling samples, and we also have part samples if needed. In general, we make those available through a direct sales motion, and you can contact HP if you've got a need there as well. We'll certainly show you, and we have small sample tools, in fact, that many of our customers have in their hands.
Brilliant. I know, because the sampling side is always great to see. And so the tools will be owned by the molders. Is that right? Is it a one-time purchase, or would the tools be leased or rented where HP continues to be involved with the molder for the entire life of the tool?
The tools are bought by the molder and used by them. If they need more, they can order more. We'll have their files in our library so that they can say, hey, I need, X more of those, or I need another screen. I want to make a screen with a different logo. We can use the digital files to produce more.
And let me add to that. If the brand is working with a molder and they have an arrangement that they own those tools, that's fine. The brand can own those tools. They may be located at the molder. So it's up to the relationship between, say, the brand, the end customer, and the molder that's running the parts.
Okay, brilliant. And I think we've got one more question coming through, which is, does HP Toolset offering include everything required for my production needs?
We do not provide the mounting plates that a tool is mounted on and attached to a machine. We do not provide anything that's metal. So what we've been doing with molders ordering tools from us is they typically have sources for those things already. And if they don't, we have a partner that we can point them to that can deliver mounting plates, after press dies, or thermoforming press dies.
Okay, brilliant. And I think we've got time for one more question. So, are there any plans for targeting South America at all? And is there a possibility of servicing clients in South America as well?
Yes, South America is certainly on our plan. We actually have molders that are interested in our technology in South America. We are not as fully supporting South America right now, but if you have production there, don't hold that back from contacting us, and we can see how we can support that area.
Brilliant. Perfect. Yeah. Well, I think that brings us to an end with all of the questions, but I want to thank you both so much. It's been such an interesting session. We've got through so many questions, and I'm sure there will still be so many more. So anybody that's got any more questions for either Eric or John, obviously head over to the website. You'll be able to send your questions through, and we will also we've recorded this session and we'll be able to send it to you post webinar, and you can share it with your colleagues as well. Thank you very much. Brilliant. Thank you so much both, and enjoy the rest of your afternoon.
Yes, you too. Bye-bye. Thank you.